Going in 8th grade. Shaking. We're going to do Unit 7, Lesson 9 today. If you haven't already, hit pause on this and get out Unit 7, Lesson 9. Lesson 9 coming at you in the fleshy fresh and freshy fresh. So smeshy smash and wishy wash. So let's catch your cash. Dude, what is he even saying? All right. This lesson is a little bit crazy, so I'm going to kind of go fast through it, and then the homework, actually, believe it or not, is where the meat and potatoes is at. So let's go ahead and do this warm-up. We're first off going to talk about how do we write huge numbers, large and small numbers using powers of 10. They save us a lot of time and effort. And eventually, this is the foundation for scientific notation. So this warm-up says match each expression with its corresponding value and word. It might be easiest if we just start with the value and the words, because you will notice you've got some things here, millicenta. Those, if you haven't guessed, are going to be the fraction when a centimeter is 1/100th of something. A millimeter is 1/1000th of a meter. Or you could have a milligram, that's 1,000th of a gram. Centigram would be 1/100th of a gram. The rest would be hopefully straightforward. If you don't know this already, you should know that, because you're going to need to know this. A 1 with 6 zeros is a million. You should know 1 with 9 zeros is a billion if you don't know that. Let's get to know it. After a billion comes a trillion. Boom shakalaka. And this one's a hard one, 1,000. Look at that. I've never drawn anything so symmetrical, not symmetrical, artistic. Now the rest, as we've talked about, if you have a 10 to the 6, that's a 1 with 6 zeros. So that one goes to a million. And then 10 to the 9th, well, that's a 1 with 9 zeros. And then 10 to the 12th, you can guess it, that'd be a trillion. 10 to the 3rd, you guessed it. Now this is where we're going to have to get used to eventually, knowing what 10 to the -2nd and 10 to the -3rd. Remember, that's 1 over 10 to the 3rd. That's 1 over 10 to the 2nd. There's nothing negative about these. 1 over 10 to the 3rd is 1 over a 1 with 3 zeros, 1/1000th. 1 over 10 to the 2nd would be 1/100th. So you can go ahead and draw those lines. And this is kind of laying the foundation for this, but I'm going to go ahead and walk us through activity 1. It says match each expression to one or more diagrams that could represent it. For each match, explain what the value of the single small square would have to be. So here we go. Match each expression to one or more diagrams. So if you look right here, I've got 2 times 10 to the -4th, and I've got 4 times 10 to the -2nd. Well, if you remember, 10 to the -1st is like 1/10, or 1 over 10 to the 1st. And 2 times 1/10 would be 2/10. And this is 1 over 10 squared, or 1/100th, times 4 would make this 400ths. So I've got 2 tenths and 400ths. Notice that this, what's most important is, again, maybe I haven't said this already, pause this video whenever you need to, or rewind it. But -1 and -2, those are only 1 power of 10 away from one another. Pay attention to this. This -1 and this -3, those are 2 powers of 10 away from one another. 3 and 1 are 2 powers of 10. This is smaller than this. This is 2 powers of 10 smaller. This is 2 powers of 10 smaller. And this is 1 power of 10. So you'll notice this is 1 power of 10 smaller. This is 1 power of 10 smaller. With that being said, you'll notice I've got 2 hundreds here, or better yet, it just depends on what power of 10 we're using, and 4 ones here. There's no 10s going on here. If you notice here, there's ones. You can let me right? There we go. There's ones and then 10s. And here there are 10s and then hundreds. So you can clearly see that this one and this one are only 1 power of 10 away from one another. This is only 1 power of 10 away from that. This is only 1 power of 10 away from that. In other words, these times a stick times 10 gives me a square, or a tiny one times 10 gives me a stick. But to go from here to here, I would have to take these and times them by 100, which is 2 powers of 10. Why am I saying all that? Is because you can see if this one is 2 powers of 10 away from one another, it's going to go with this one and that one, because I've got 2 of something, 1, 2, and 4 of something, and here you can see 2 of something and 4 of something, 2 of something and 4 of something, which means this, I've got 2 of something and 4 of something, can go to that because it's only 1 power of 10, and it can also go to that one. Now, it might not make a whole lot of sense, but it's just having us recognize powers of 10 and how they can be zoomed in or zoomed out. It's not always like it was back in first, second, third grade, where maybe even a little bit beyond that, where everything is just 1, 10s, and hundreds. We can zoom in on these and pretend that they are thousands and 10,000s and so forth. So it does say, for each match, explain what the value of a single small square would have to be. In this case, if this is 2 times 10 to the third, and that's 4 times 10 squared, then each square is just 10 squared, or each square is 100. And then over here, well, it could be 100 in this case. Over here, if we're using this one right here, because that also was a match, well, 10 to the negative second, in this case, that square was 1 over 10 to the second, or 1/100th. All right, so let's, well, technically, yeah, let's move on. Well, I guess we got to figure out these two, but this 10 to the negative third, if we're looking right here, well, that means each square was 1/1000th, or I'm just looking at that. 10 to the negative third is 1/1000th, or 1 over 10 to the third. And over here, if we're going right here, well, 10 to the first is just 10. One of those squares would be 10. And then it says, write an expression to describe the base 10 diagram if each small square represents 10 to the negative fourth. So this tiny square is 10 to the negative fourth. Well, if I took this and times it by 10, I'd get one of these. So if that is 10 to the fourth, then one of these is 10 to the negative third. I'm not sure. I don't know if I explained that really. 10 to the negative fourth, by the way, is 1 over 10 times 10 times 10 times 10. Because that's what 1 over 10 to the fourth. Times 10 means I put a 10 on top, which means this one and this one can cancel, which means I'm left with 1 over 10 to the third, which is why I wrote that right there. And if I times this by 10, I get 10 to the negative second. So each one of those is 1/100th. So it says, write an expression. Well, there's two of these. There's two 10 to the negative seconds. Plus, there is 1, 2, 3, 4, 5 of these 10 to the negative thirds. And then there is plus 4 of these 10 to the negative fourths. So a lot going on there, but hopefully you're just recognizing this is ways that you can write very big or small numbers. But what's most important is we're going to jump. This would be a fun activity, but it'd be kind of hard. Let's look at this lesson 9 summary, because this is actually what we need to know, which is kind of annoying that the lesson doesn't really zero in on this, but the homework does. So we'll get to that in just a second. It says sometimes powers of 10 are helpful for expressing quantities, especially very large and small quantities. For example, the United States Mint is made over 500 of something. Well, here is hundreds, thousands, millions, billions, 500 billion pennies. In order to understand this number, we have to count all the zeros. Since there are 11 of them, that means there are 500 billion pennies. Using powers of 10, we can write this as 500 and 10 to the ninth are billions. Or, that's one way to do it. Or, since there are 11 zeros, like it said there, we can write this as 5 times 10 to the 11th. 10 to the 11th is a 1 with 11 zeros. Times that by 5 would be a 5 with 11 zeros. So it's really important that we understand that this and this are the exact same thing. 500 times 10 to the ninth is the same thing as 5 times 10 to the 11th. Now here is a hard rule that we have to learn. I'll leave that there. How would I write this as a power of 10? Right? A single atom of carbon weighs about whatever that is, 0.00019, right? And that's a true story, right? Obviously very light, as you can tell. An atom does not weigh much. Now, we can write this as a power of 199 times 10 to the negative. Where do you think this negative 25 came from? Well, that would be the same as 1 over 10 to the 25th, right? Which would be a 1 with. But if you look right here, if I start right here and I started counting back at the end, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and look at that. I didn't think it would work out. 25. It took me to go from one side of the number 25 place values to get it back to the decimal, which is a shortcut. It's kind of a math hack, which is why we say I've got to go back 125. Now that's if I started 199 and I started right there, right here. Got it? So if I started right here, I got to go back 25. But what if I start right here, like this is doing? What if it says right here? Well, I don't have to go back 25. I've already got a 2 head start, which means I only have to go back 23, which is why this, or better yet, this is the exact same thing as that. Now, why are they doing it 2 different ways? Well, not to let the cat out of the bag, but guess what? This and this And we don't need to know this yet because we're not there and we won't be there for a couple lessons. But these two, the last ones that they mentioned, that's what we call scientific notation. These are just ways of writing big numbers with powers of 10. They're still great. You can still use it. 10 to the 9th. It's known as a billion. 10 to the 6th. You can easily tell someone how many millions there are. But eventually we're going to put everything in scientific notation because it's very easy to compare them. Now let's look at grade 8, unit 7, lesson 9. Practice problems. Go ahead and turn to whatever color pages you guys have. Can't keep track. No, green pages. So you can match each number to its name. I'll let you do that. You don't need my help with that. I hope not, because this is very similar to the warm-up. Anytime, though, just a hint, anytime you see TH, it's going to be a decimal, right? If you don't see a TH, it's just going to be but here is what we need to learn. If you haven't figured this out, no big deal. Let's learn it right now. Write each expression as a multiple of a power 10. Let's face it, we could all actually write many different answers here, right? If you want, one way of doing this is just saying, okay, how many zeros are there? There's 2. So I could say this is 423 times 10. And since there's 2 zeros, I want to times it by 100. That's a power of 10. Here there are 3 zeros. I could say that's 2 times 10 to the 3rd. Now, you could also, you don't have to, if you wanted to go ahead and start, although actually that last one was correct, so ignore that. That wasn't. If I wanted to, I could also, now you don't have to, just leave it as is. I could say this is the same as 4.23. And if I took this and I times it by 10, by 100, by 1,000, by 10,000, that's 1, 2, 3, 4. I could also say this is 4.23 times 10 to the 4th. I don't have to, but give you a little heads up, I just wrote that in scientific notation. Again, we'll talk about that. But for now, if you want to just write as powers of 10, you can just go ahead and say, okay, there is 5 zeros and the number 92. So I could say that is 92 times 10 to the 5th. You can go ahead and write that. So 4,000, again, that's going to be a 4 with 3 zeros. So you could say that's 4 times 10 to the 3rd. Now, the reason why we kind of did that warm-up is because, remember, million has 6 zeros. Billion has 9 zeros. So 80 million would be 80 times 10 with 6 zeros. 32 billion would be 32 times 10 to the 9th power. Now, those aren't in scientific notation. It's not asking us to, and we'll get to there. That lesson's coming up. But for right now, that will be good enough. These are all writing big numbers and powers of 10. So, each statement contains a quantity. Rewrite each one with a power of 10. Well, let me give you a clue. Here's 37 trillion. Trillion is, if you remember, 12 zeros. Got it? So that would be 37 times 10 to the 12th power. Billion, well, that one's just like this one. So that one's going to look just about the same way. A sharp knife. Oh, this one's hard. This is where, I'm not going to lie to you, I don't know of a shortcut with these, because doing millions is not like, well, maybe it is actually. I take that back, because a millionth, remember, we're going to be talking about 10 to the negative 6. If you really wanted to, it's 1 over 10 to the 6. So that's nothing other than 23 times 10 to the negative 6 power. A certain wall would be 4 nanos. Certain wall of a certain cell in human is nanometers. Nanometer is 1 billionth. That's going to be 10 to the negative 9th. Well, all we got to do is put a 4 in front of that. Billion would be 9, so a billionth would be 10 to the negative 9th. So that was a little bit easier. Now, I'm going to let you guys do problem 4. It does say a basketball. Can anyone remember how to find the volume of a basketball? If you need to, hit pause, go into Google and type in the volume of a sphere, and it'll tell you it is 4/3 pi r cubed. Okay, so you actually don't have to go because I just told you. So use that formula. Boom, plug in the numbers. It tells you express your answer in terms of pi and using 3.14. And you'll get your answer pretty straightforward. Here's some good review on some equation solving. Hopefully remember how to do the distributed property. This one down here would be something like 31 equals 5b minus 10. You could try to divide each side 5 ways, but you're going to be left with not a very friendly fraction. You're going to be left with not very friendly fraction to begin with or to end with, but either way, that should be hopefully a good refresher. This one can be solved many different ways. You might have to write 3x minus 2 equals 7 minus 6x. What would we do first? I personally would like adding 6x first. Then I get 9x minus 2 equals 7. And I'll let you finish it from there. And then finally, problem 6 says graph a line going through negative 6 comma 1. Negative 6 comma 1, that's right here, with a slope of negative 2/3. That means starting there, it's going down 2 over 3. Down 2, I should say down 2 over 3. Down 2 over 3. Down 2 over 3. And guess what? That's enough information for us to be able to write its equation. Y equals mx plus b. M is the slope. B is the y, or vertical intercept. And all I got to do is swap out m with the slope and b with the y-intercept, and I have its equation. We're going to call it good. You guys finish the rest of this on your own. I hope you all have a wonderful rest of your day. Peace.